Hello, everyone. Hope you are doing well. I pray for your safe and healthy life. I'm really grateful for your interest in this video. This video is related to the our international webinar PSA002 for the Hazardous Area Classification. This actually course PSA002, a one-day free online international webinar on Hazardous Area Classification. Its lecture was delivered by myself, Yashpal Singh, and the date was 22nd February 2026. And this lecture video is also available on the YouTube, our channel, Yashpal Singh HSC Pathshala. That was for these 6 hours, started from at 10 a.m. Indian time, and we ended at 4 p.m. Indian time. So this video is related to the answers of the questions raised during the session, which we could not respond because of limitation of the time. So this video, we have total 28 questions raised by the participants. So actually, during the training session, during the webinar, international webinar, the standard which we explained were Indian standard, NFPA, and IEC. So Indian standards for the vapors, gases and vapors were IS 5572, and for powder, IEC 61241-10, and NFPA standards, NFPA 497 and 499. One was for gas and one was for powder. And of course, IEC 60079-10-1 and IEC 60079-10-2. But here, all questions we received were related to the IEC standard. So we are giving the response in this video that is related to the IEC 60079-10-1 and -10-2. So let us start with the first question. So first question is, do we need to calculate average LEL when dealing with the mixture of the gases? So answer, not always. According to the guidance for hybrid mixtures, a mixture can become explosive even outside the individual explosive limits of the components. So as a conservative approach, we have to give here. So that is the worst case scenario. So if detailed data is not available, it is always recommended to assume the mixture is explosive when gas or vapor concentration exceeds the 25% of the LEL, or dust concentration exceeds 25% of the maximum explosive concentration. So in that way, we have to consider the individual LEL, and as per the guidance, we have to check if exceeding 25% LEL or 25% of MEC, then we have to consider hybrid mixture as explosive mixture, and we should go ahead with the calculation. So this conservative rule is used because hybrid mixture can have stronger explosion characteristics than individual substance. Therefore, the mixture should be treated as hazardous event if each component is below its own explosive limit. Now, question number 2. How do we determine the boundary for zone 1 and zone 2? So there are basic calculation for determining the boundary of zone 1 and zone 2. But in general, we can summarize that zone boundaries are determined based on grade of the release rate that we calculate, which was explained in this workshop also. So you can refer the video. So here we will share the link of the video in the description of this video. That is link of the 22nd February Hazardous Area Classification online international webinar. Complete video, we will share the link in this description of this particular video, question and answer video. So you can check how to calculate the release rate, then ventilation effectiveness, gas properties, dispersion behaviors. Through this, we can determine the boundaries for zone 1 and zone 2. Question number 3. Is there any software available to perform QRA? Yes, there are a lot of software available internationally and in India also. So commonly used tools includes FAST or Safety. Both are same thing, but FAST have some limitations. Safety is full-fledged QRA software, and of course Aloha, which is accepted in India and approved by the Ministry of Environment and Forest. So you can use. Aloha has a limitation, but that is a free software, whereas FAST and Safety has a lot of charges. So as per your requirement, you can use these tools. Question number 4. Is there any difference in hazardous zones for different industries type? The classification methods remain the same irrespective of the industry, but zone extent varies depending upon type of process, material properties, operating conditions, ventilations, all these things. So, response to the question, there is no difference if industries change. So, only difference depending upon the calculation methods. So, question number 5. For a cooling tower with an ejector system handling flammable liquid, should it be considered zone 1 or zone 2? So, if there is a ejector system handling the flammable liquid, so there is always a possibility of vapor going to the cooling tower through the ejector. And there, in case of abnormality, of course, there is a more concentration of flammable chemical may go to the cooling towers. So it generally depends on the frequency of the release and ventilation conditions. If flammable vapors is likely during normal operation, it may be zone 1. If it occurs occasionally, it may be zone 2. So in the previous question, we are talking about the cooling tower vapor atmosphere. So of course, moisture is there, so normal there's always less chances, but depending upon the conditions, we can consider. Now, question number 6. At the vent of the tank, oxygen concentration may be always LOC. Will this area be hazardous? So, answer yes. Vapor release from the tank mixed with the air at the vent, forming a flammable atmosphere. So, the vent area is typically zone 1 or zone 2. Question number 7. How do we decide the hazardous zone area in the meters? Okay, so there are steps for the calculation, which was again explained in the international webinar for the hazardous area conducted on 22nd February. Please refer the link in the description and you can check it. So step 1 is calculate the release characteristics. Step 2, determine the dispersion type. Third is read the hazardous distance. So it is step by step explained. Please refer that. Now, example interpretation using the figure. So we have to use this figure ultimately to finally decide the hazardous distance or radius. So from the mark point in the figure, if you go there, so release characteristics 0.1 meter per second. So using diffusive dispersion blue line, because we have to see whether gas is heavy, diffusive or jet. So accordingly, we have to select the line. So that we get through our steps calculation, which is explained in the webinar. So suppose it's a diffusive gas. So considering the 0.1 here, 0.1 release rate, if you check, so our this hazardous radius is in between 1.5 to 2. So we can consider 2 for the worst case. So the estimated hazardous distance is approximately 1.5 to 2 from the graph. This means the zone 1 or zone 2 boundary may extend about 2 meters from the release source, depending upon the grade of release and ventilation. So this is how we interpret. Now, question number 8. How should we consider the hazardous range from the charts? Same as discussed previous one, but in that case, if we want to go in detail, please refer the webinar link. Question number 9. From the temperature classification chart, is T1 the safest class? So T1 is highest allowable surface temperature, and T6 is lowest allowable surface temperature, meaning T6 is the safest, which can be used for all the temperature class. So if you select the T6 classification for your equipment, so that is you can use for all the temperature classification T1 from T6. So in case of lower class, T6 is requires stricter temperature limits that we have to know. So in case of T6, the surface temperature should be maximum, say 85. So if your surface temperature is 450, you are using T6 of 85. So that is fine because it is more than 85 is more than 450. So 450 is much safer. So you can use it, of course. So our answer that T6 is safest one. Question 10. If a PSV is used instead of vent in a fixed roof tank, what will be the zone classification around the tank vent? So basically, if we have PSV, now we have to see release from the PSV is regular in case of abnormal condition. So if it is a regular, then it's a zone 1 discharge, that is, if there is a regular discharge from PSV near the discharge point, so it's a zone 1. Zone 2, if there is a discharge in abnormal conditions from the PSV. We have to go refer the definitions on these responses respect to the definitions of zone 1 and zone 2. Now, question number 11. How do we select temperature classification and how does it work? So, temperature classification is selected based on the following criteria. For vapor, it's the autoregulation temperature of the gas or vapor, and for basically powder, minimum ignition temperature of the powder or layer ignition temperature for the dust. Then you have to refer the table which we discussed in the previous question. Now, question number 12. Do we have immediate ignition above UEL? No, above the upper explosive limit. Normally, ignition is possible in between LEL, lower explosive limit, and UEL, upper explosive limit range. So, if concentration is above upper explosive limit, so in that case, when dispersion starts, slowly it spread, and after some time, that mixture will achieve the concentration below UL, and at that time, if ignition is there, so that will explode. So we can say if concentration is more than UEL, so it's a delayed ignition only. Now, question number 13: which chemical properties affects dust explosion risks? Of course, so the key properties include minimum ignition energy, minimum explosive concentration. So MIE is related to the temperature. If you see the triangular quadrant, so MIE is related to temperature, minimum explosive concentration is related to fuel, particle size is the one additional criteria here. It's like a pentagon, you can say. So particle size, which should be less than 500 micron. For IC, I think it's less than 450 micron, which is explained in the international webinar. Moisture content, if moisture is more, so it will reduce the explosivity. So reactivity, of course, is there, and limiting oxygen concentration. So these are the key properties leading to dust explosion risk. So what is the difference between grade of release, zone 0, 1, and 2? It's a basic definition. Grade of release, frequency of release, that is continuous, primary, and secondary. So if you see the zone classification, hazardous area categories based on the probability of across the atmosphere, zone 0, 1, and 2. You can refer the international webinar video, which is shared in the link, in the description. Link is shared in the description. So in detail, it is already explained there. Question number 15. What is the difference between HAC and ATEX? Good question. Actually, HAC is Hazardous Area Classification Guideline, which identifies the hazardous zone, where ATEX is a European directive regulating equipment used in the hazardous area. So basically, we can say HAC is related to how to define the hazardous area, and ATEX gives the criteria or regulations, guidelines, how to select the equipment in particular hazardous area defined through the HAC. So both are complementary to each other, but independent. Question 16. What is the difference between gas group and temperature class? So gas group are based on the properties of the gas, that is 2A, 2B, 2C, relates to the explosion characteristic of the gases, whereas temperature class relates to the maximum surface temperature of the equipment. So again, we select as discussed in the previous question. Question 17. What is criteria for grouping gases like 2A, 2B, 2C? So gas grouping mainly depends on the maximum experimental safe gap, MESG, and minimum ignition current, MIC. So that is already discussed. How can we prevent dust explosion in zone 20, 21, 22? So answer is prevention method includes dust control and housekeeping. So and release, we have to control the release of dust and maintain proper housekeeping as per the guidelines. Then we can increase the ventilation. If we will increase the ventilation, we will provide the adequate ventilation in case of the closed rooms as per the international standards for the ventilation. That is the change count, if we maintain the change count. Or otherwise, in case of the equipment, if we have this negative suction, so we create the vacuum in the equipment, so explosive mixture concentration will not achieve, and through this method we can prevent. Next is explosion venting or suppression device. So if we provide the explosion venting like we design the PSC for the explosion cases, or we install the suppression device in the equipment. Next is intrinsically safe equipment. That is the one thing. Next is monitoring ignition sources through different methods and initization in the equipment. So these are the few methods by which we can prevent the explosion in the equipment or in the work area. So question number 19, if two gases have the same LEL and UL, why is the one with higher vapor density considered more dangerous? A good question. Gases with higher vapor density accumulate near the ground. So if gas is heavier, then it will accumulate on the ground to the higher concentration buildup and larger hazardous zone. So if higher heavy gases accumulating on ground, so concentration buildup is more and hazardous area distance or hazardous radius will be higher. So that is why it is considered more dangerous. Question number 20. For petroleum products with flash point above 93, should we still consider HAC? Yes, if the product is combustible, even though they are less volatile, HAC may still be required depending upon the operating temperature and release condition. Question number 21. In floating roof tank, there may not be vapor space. How does HAC apply? So floating roof, minimum vapor space, but rim seals and the fittings can still release the vapors. So that they are creating the zone 1 or 2. So we should consider this one. Question number 22. If the tank is nitrogen blanketed, is the inside vapor space still zone 0? So basically, qualitatively, we can say no. But when we go in a quantification, so of course, as we know that uh, we have to ensure that oxygen concentration is below limiting oxygen concentration. So normally, the interior of the process equipment is often considered a hazardous area if even if the flammable atmosphere is not normally present. This conservative approach accounts for the probability of air entering the equipment, which could create a flammable mixture. So there is a one option. If qualitatively, of course, for the safer side, we should consider because we do not know what is the concentration of flammable mixture inside, and that depends upon the pressure also, and what is the concentration of oxygen. So, however, IEC 60079-101 provides an important clarification. If specific control measures such as inerting are implemented and reliability maintained. So, reliability can be through the validation or by installing the oxygen meter in the equipment. Through this, we can maintain the reliability. Second part of the reliability is we should ensure the continuous nitrogen supply at continuous flow, similar flow rate, what is as per the validation. So we have to provide the flow meter also in the nitrogen supply. Through this, we can maintain the validation or we can maintain the reliability. Second is the interior of the equipment may not need to be classified as a hazardous area in such cases. But of course, reliability should be there either through the nitrogen flow or through the oxygen sensor. The next question is 23. What is the significance of relative density? There is a vapor density in HSE. So relative density or vapor density compared with the air affects how a flammable gas or vapor disperses in the atmosphere, which directly influence the shape and extent of the hazardous zone. So according to IEC guidance, horizontal extent of the hazardous zone at ground level generally increase with the increasing relative density. The vertical extent above the source generally increase with the decreasing relative density. Again, this has the role in the calculation also. If you see here, vapor density heavier than air means relative density is higher. So behavior gas sinks and spreads along the ground. So HSA impact larger horizontal hazardous area. Lighter than air means relative density is less than 1. So gas rises and disperses upward. So greater vertical hazardous extent. So larger horizontal hazardous area is more dangerous than vertical. Of course, in case of there is a different floors are available, so vertical also dangerous. Suppose we have more than one floor, so that is also available depending upon usage of that floor. Question number 24. How is HSA applied to natural gas system? So natural gas system typically involves zone 1 near the release point, valve flanges, and zone 2 in surrounding areas depending upon the ventilation and you have to refer the definitions also. Question number 25. Will the extent of hazardous area classification differs between standards? Yeah. Major, sometimes there is a major difference. Standard may give different zone extent due to the different methodology. Basically, Indian standard and NFPA is, we can say, it's an example method, more qualitative, whereas ICE is quantitative. So, in case of Indian standard or NFPA, there are some general example. In case of no example is available, you have to select closest one. So ranges varies. In that case, IS and NFPA, the hazardous radius will be more. While if you calculate as per the ISA guidelines, so you will find lesser one, so more specific. There are other difference also, like in the flash point also. Indian standard says something different, NFPA different definitions, and ISA has different definitions. So even in the case of the dust particles, particle size for the explosion in the Indian standard different, NFP different, like that. So of course, because of this, there may be a different action zone because of methodology. Question 26. For coal dust, what classification applies? So coal dust typically falls under class 2 hazardous location or dust zone, that is zone 20, 21, 22. So it's a dust, so it's a 20, 21, 22, depending upon the standard used. The zone 20 explosive dust cloud present continuously for longer period frequently. 21 explosive dust cloud likely to occur occasionally during the normal operation. Explosive dust cloud not likely in normal operation. If it occurs, it exists only for a short time. So you can refer the definition. This is explained in detail in the webinar also. And of course, we have to refer exactly. But if you want to see the continuous means clarification of continuous, uh, likely in case of 21 and leakages in case of 22, so you can refer the IP also. So their hours are also mentioned, uh, for how many hours we should consider continuous, for how many hours we should consider 21 as a primary, or 22. So that is, you can refer IP 15 also. That is for the vapor space, but just for the understanding, you can refer that. Question number 27. From particle size distribution, can we determine whether a powder is combustible? No. PSG alone cannot determine whether a powder is combustible, but it strongly influences explosion risks. And for the possibility of explosion risks in the powder, you can refer the previous questions, which are already explained. The combustible dust must be confirmed through the following ways. First is initial screening. That's a quick check. So likely combustible dust like sugar, flour, starch, wood, coal, plastic, aluminum, magnesium, zinc, iron, charcoal, carbon black. I think these are detailed. The names are listed in the NFPA. So NFPA is better if you want to understand for uh, likely combustible dust, and likely non-combustible dust are also given in the as a list in the NFPA. You can refer that. So likely non-combustible dust may be sand, silica, limestone, cement, gypsum. So practical decision logic, if is it a fine particulate solid? No, so no dust hazard. Yes, so continue. You can follow the particle size also in this case. Second, can it burn in the bulk solid form? If no question is no, so likely non-combustible. Question is yes, so you have to continue for this step 2. For finding the explosion rating. So these are the two steps by which you can define combustibility of the powder. Now, question number 28. If an LPG propane storage facility is located inside a boundary wall and includes multiple equipment such as storage tanks, unloading pumps, vaporizer, and truck loading, unloading platform, how should the hazardous area and zone classification be determined? So, according to IEC 6007 and 10-10-1, hazardous area classification is performed for each potential release source, not for the entire storage yard. So, it may be possible that from one equipment hazardous area may overlap with the other, but that is the only option that you have to check for each and every equipment. So thank you very much for being with us till the end. Thank you. I'm really grateful that you you had the interest in this video. Uh, Please connect with us. Please subscribe our channel. Please click the notification bell so you will get the notification. Now we will increase the these videos, and we'll try to post as much as possible with more information. Thank you for being with us. Thank you very much.